Yep. We can't see anything. Start.
Recording in progress.
Disconnect the audio and start. Okay. Okay, bro. Now, simple harmonic motion. Okay. Simple.
Sir,
Yes.
what topics did we finish up until now?
The gravitational field and the gravitational potential. Okay. And the circular motion. Okay. These are the three things that we have finished at. Okay. And now we are going for the third topic, and that is simple harmonic motion. Okay. Fine. Mm, okay. Let's begin. Perfect. Come on. Okay. So basically, in this chapter, we are going to discuss some of the concept of the oscillation. Okay. And let me start. Where is the red gone? Okay. So I'm doing it with purple. Okay. So oscillations. Also, okay. So, bro, oscillations. Okay. So oscillation is basically the repetitive motion. Okay. And we discussed the concept of the repetitive motion previously. Okay. So over here, over here, we first have to categorize the motion into two different types. Okay. And they are the part of the oscillation, or they are the part of the repetitive motion. Okay. So if we consider the repetitive motion, so let me just write the repetitive motion. Okay. So the motion that repeats itself, we are discussing that. Okay. And okay. So in this type of motion, we have like few things that we have to discuss. The first thing is, अच्छा जी. The first thing is the periodic motion, okay, and the second thing is the oscillatory motion, okay. So a periodic motion, okay, and we have the oscillatory motion. Okay, so we have the periodic motion and we have the oscillatory motion. It's not working perfectly. Let me just find, and हमारे पास yeah A2 A2 over here, and yes. Okay, so periodic motion is a type of motion, is a type of motion that repeats itself after a specific period of time. Okay, so it repeats itself after a specific mm, so it repeat itself, okay, after specific period. Okay, this is a simple harmonic motion we have. This is the oscillate, or this is the periodic motion that we have, right? So if you want the example, so examples are the circular motion. So yeah, circular motion. Okay, and we have the gravitational planetary motion, planetary motion. Okay, or you can think of any circular motion or any motion that repeats itself after a specific period of time. Okay, that is basically the periodic motion. Okay, now the oscillatory motion on the other end is basically the motion that repeats itself from the fixed position. Okay, or from the specific position. Okay, so from the specific position it repeats itself. Okay, so it repeats itself after a specific, sorry, after, not from, from, after, repeat itself from specific position. Okay, okay, so from the specific position or location, specific point, let's say. Okay, so this is basically the oscillatory motion. Okay, you can consider, you can assume two type of oscillatory motion. Okay, one is basically the back and forth oscillation. Okay, and the up and down oscillation. Okay, okay, the vertical oscillation, the horizontal oscillation. Okay, you can say the vertical oscillation and the horizontal oscillation, till oscillation. Okay, let me just, horizontal till oscillation. Okay, and basically, but in both of the cases they repeat themselves from their specific position. Okay, vertical oscillations are like the pendulum, sorry, are like the spring mass system, and the horizontal oscillations are like the pendulum. Okay, so I have the pendulum with me. Let me draw it for you. Okay, so this is the horizontal oscillation. Okay, the vertical oscillation is basically the spring mass system. Okay, so you can imagine the spring mass system as, maybe if I just take this base, bro, come on. Okay, so right here, and just move it to the other side right here. Okay, I have some springs in my collection. Okay, here it is. Okay, so a spring is added. Okay, and you can add the load. Okay, you can add the load in it, so it will start moving. Okay, so this is the load I have. Okay, so the vertical oscillation and the horizontal oscillations are look like this, okay? And you can imagine any of the oscillation that are vertical and that are horizontal, right? It's just the example, okay, that you can think. And both of the things are basically you studied in your O levels, sorry, AS level, right? The spring mass system is the deformation is in the deformation of solid, and the second one is in P3, right? So I think you remember that, right? Like where you do the oscillations, okay? So these are the two type of oscillations we have, okay? The vertical oscillation and the horizontal oscillation, right? And after that, by the way, they repeat themselves from the specific point, and they also have a specific time period, right? So all the oscillatory motion are basically a periodic motion as well, because they have the period as well, okay? And but all the periodic motion are not the oscillatory motion, right? Because they don't have any specific position, right? Like you don't know where the earth first started oscillation or first started moving, right? Because earth is moving around the sun in a circular motion, and it take 365 days approx to complete one of its oscillation, right? Or one of its motion, one of its period, right? So but you don't know where uh where was the earth started at first, okay? No, bro, I don't mean that. For till now I didn't mean amplitude yet, okay? Okay, fine. So this is a vertical motion, ampere. No, okay, fine. Just skip it. Okay, so these are the two type of motions that we have. Okay, but for now, we discussed the concept of the circular motion in the previous chapter, planetary motion as well, and now we have to discuss the concept of the oscillatory motion. Okay, and in oscillatory motion, we have the vertical motion, we have the horizontal motion, right? And in vertical and horizontal motion, we basically have um two cases. Okay, one where we consider the free motion, right? Nothing. Okay, just write the spring mass system. Okay, and you have the pendulum. Okay, now we have two different type of oscillations we have. Okay, so oscillations oscillations can be of the two different type. Okay, they can be free oscillation or they can be the forced oscillation. Okay, free oscillation and the forced oscillation. Okay, so we have the free oscillation and the forced oscillation. Okay, so forced oscillation. So at the end of the chapter, we will going to discuss the forced oscillation, and initially we are discussing the free oscillation, right? So by the way, we analyze the oscillations into like three different things. The first is the kinematics. Okay, we analyze the oscillation in terms of kinematics, and then we analyze the oscillation in terms of um, forces, and then we analyze in terms of energies. Okay, so these are the three things that we can analyze the oscillations of. Okay, now let's start the kinematics analysis for the for the SHM, simple harmonic motion. Hmm. We have, come on, kinematic analysis. Okay, so this is the first thing. So in kinematic analysis, we have some of the quantities that we remember. Okay, the first thing is the displacement, the velocity, and the acceleration. These are the three main things. Okay, we are not going to discuss the speed and the distance, right? Because they're not required, right? Uh, okay. Now, The first quantity is the displacement. Okay. Now we have to understand how the displacement looks like um, in the pendulum or in the simple harmonic motion. Okay. So I have the text. Okay. So the first thing is the displacement. Okay. This is the first quantity that we are discussing. Okay. Now this is the displacement. Okay. So imagine a pendulum, okay, and imagining the pendulum, we can use a displacement, okay. By the way, you know that displacement in the simple harmonic motion or displacement in the wave is basically the distance. Wait, the distance moved by the object from its mean position, okay, to any point. Okay, but since it is a displacement, so we can say that in a specified direction. Okay, direction, right? Okay, now if we try to sketch the if we try to sketch the displacement of the pendulum, so let's imagine a pendulum. Okay, I have this pendulum right here. Okay, initially, initially it is like it is right at the mean position, right? And let's say I just push it and it start moving, right? So I just want to draw the graph of how the motion of the pendulum is. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Okay. So, so now initially, mm, nope, it won't work. Wait, wait, wait. Okay. So initially the pendulum is at its mean position. Okay. And let's say right here. Okay. At some time. Okay. It reaches its maximum position. Say let's say the maximum position is right here. Okay. And then it get back to its mean position again. Okay. In a time of, if I just draw it perfectly, so let me just draw it right here. Okay. Right here. Come on. सीधा सीधा नहीं बन रहा. Two, एक second. 2, 4, 6, and 8. Okay. Let's say these are the time. Okay. I just want my graph to be perfect so that it would be easy for you to understand. Okay. So at that point, the pendulum was at the maximum position, and then it get back to its mean position again, and then it moved to the other point, okay, in the opposite direction, right here, and then it get back to its mean position again, right? Which means if I draw the graph, so the graph would look like this. Wait, let me just change the color to this one. Okay. Okay. So, and this one. Okay. So this is how your oscillation looks like. Perfect. Now, if I just show you the position of the pendulum, so initially the pendulum would be at this point. Just make it smaller. Okay, so initially at this point, okay, and at mean position, it will again be at that point, okay, and then at last, it will end up at this point again, right? So these are the three main position, okay. Come on. So these are the three mean positions, okay? And now at the end position, like the maximum and the minimum, so you can imagine it that way, okay? So let's say over here, it is just moving in this direction, okay? Okay, so it's just moving in this direction first, okay? And then at that time, it's moving in the opposite direction, like that, okay, like this. So this is how one complete oscillation should looks like. Okay. Now, can you guys predict the graph or predict the equation that corresponds to this function? If you had maths in your AS level, so you can predict me. Anybody? Yes. Can anybody predict the equation regarding this function? Anyone, please? Yes. Nobody? Very good, bro. It's a sine curve. Yes. So this is a sine curve, okay? And so can you okay, let me just give you the values so that you'll be able to write the equations yourself, okay? And the last one is this one. Okay. Now, if we say, let's say, uh that this maximum point is a point where the displacement is maximum, let's say x naught, okay, and on the y-axis it is the displacement, okay, and on the x-axis it is the time, okay. So displacement and time in seconds, right? So if I try to make the equation, okay, so I can say that x is equals to x naught, and I have sine theta, right? We can say, or we can rather say that as sine, okay, sine theta, right? So you know that omega is equals to theta over t is the formula, okay? And you can replace the theta with omega times t, okay? And now your formula will become x naught sine omega t, okay? This is the formula that relate this equation, okay? Acha. Mm, fine and fine, perfect. Okay. Now, if I rearrange the things a bit to remove, by the way, I just remove it. So if I just say that, so the W is omega basically. I'm explaining, wait. So this X is basically the displacement, okay? This omega is the amplitude. This is the displacement amplitude, okay? And this is omega, and this is the time instant, okay? This is the time instant. This is the time instant, okay? Now, just note down the value. So this is the instantaneous displacement, okay? Instant instantaneous displacement. Okay, this is the first thing, right? This is the amplitude. Instantaneous displacement mean displacement at any time instant. Okay, and this is the amplitude. Okay, amplitude. This is the angular speed. This is the angular. In this chapter, we'll be calling this as angular frequency. Okay, angular frequency. Okay, and if you just move it to the other side. Okay, so t is basically the time instant that you're working at. Okay, so this is the time instant. Okay, so acha, by the way, angular frequency has a symbol omega. Okay, and it is given by 2 pi f or 2 pi upon t, 2 pi over t. Okay, so this is the formula that you should remember for this one, for this portion. Okay, now Acha, by the way, this time is basically the capital T, okay? This is the capital T. This is the time for one whole oscillation, okay? And this small t is basically the time instant from this starting to any point. Like if you're working at this point, so you have to consider the time t. So this t is basically this one, right? But if you find the omega, then you have to consider the whole time period, okay? For one oscillation. Clear? So this is the time period, okay? Period. Okay. You should remember the definition of the amplitude as being the maximum displacement from the mean position, okay, in any direction. Okay. So okay, so this is the displacement. This is the displacement, and this is how the displacement varies in simple harmonic motion. Okay, it could be a cos graph, it could be sine graph, negative cos or negative sine graph as possible, right? Is also possible because if let's say if somebody displace it at that point, okay, and he releases from this point and start measuring the time period or start measuring the things, so his graph starts from the maximum value and then it looks like this, right? So it depends. Okay, we consider one scenario and then we are doing the things accordingly, right? Okay. Now, okay. So sometime sometime they give you the exemplary equation and they ask you to find out the remaining things or missing things. Okay. So let's imagine that you have x is equals to 15 sine 50 or 36 pi t. Okay. Let's say this is the equation given, okay, to you. Now they're asking you to find or to state the amplitude and state the angular frequency and time period and blah blah blah. Okay. So let's say this is the equation that they have given you, and they're asking you to state the okay, state the amplitude, amplitude, okay, the angular frequency, angular frequency, and the frequency and the time period. Okay. So, so what will you do? Can anybody tell me how will these things, or what will be these things? Yes,
Amplitude is 15
very
and
good.
angular Angle frequency is 36 pi divided by 2.
36 pi only. Divide when
Uh,
you divide that by 2, you'll get frequency then, no? Because if you just compare it with the original equation, so x naught sine and this whole thing is omega and this thing is t, right? So this whole thing is omega, so you just need to copy paste it, okay? Very good. So, and the frequency is going to be the omega is 36 pi, and omega is basically equal to 2 pi f. So pi and pi goes off, so it will be 18. Yes, getting?
yes.
Okay. And when you divide that, when you do 1 over 18, you will get the time period. Okay. How much? Yes. How much? Do you have anybody calculating?
1 by 18?
1 by 18, yes. So it would be 5.55 exponent negative 2. Okay. So 5.56 exponent negative 2 is the time period, right? You can also find the instantaneous. Okay, if you draw the graph, by the way, for this function, so the graph would look like this. इब्राहिम समझ रहा है भाई? Okay, so this is how the graph looks like. Now, so that would be 15, okay, and that should be negative 15, okay, and the time period is 5.56 exponent negative 2, okay, and let's say if we try to find out the value at that point, okay, like the time value or the displacement value at this point, okay. So this is the point we have. Come on, एक circuit ही नहीं बन रहा है. Okay, so let's say we have to find out the displacement at this point, okay. The displacement x, okay. So the time is given to you. The t at that point is, let's say, it should be smaller than half the value. So 2.0 exponent negative 2, okay, 2.02 exponent negative 2, okay. Now to find the displacement at that point, okay, you just need to put in everything in the equation, okay, and you can solve, right? So x is equals to 15 sine 36 pi in t, right? So just put t in it and you'll get the value, right? So 15 sine 36 pi, sorry, 36 pi, and then you have 2 exponent negative 2, okay? And you'll get the answer, okay? But make sure that your calculator should be in radian, not degrees, okay? So 15 sine 36 pi into 2 exponent negative 2. I am getting the displacement as 11.55. Okay. So the corresponding displacement is 11.55. Okay. Or 11 point, you can round it off to 11.6 centimeters, right? Is that clear, guys? Now, so we understand the concept of the displacement time graph. Let's do the velocity time graph. Okay. So I have the other quantity as a velocity. Velocity. Okay. Okay. So velocity is basically the rate of change of displacement by definition. Okay, the definitions is not required. Like the O levels definitions are not required. Okay, or the AS level definition for now is not required. I'm just writing it for the E is the rate of change of displacement. Okay. So to understand the concept of velocity, we have to consider the displacement graph first. Okay. So let me just take this one. Okay, and come on, and I'll be doing the things according to this graph. Okay. By the way, can you guys tell me if I am using the graph? Okay, if I'm using the graph, so can you guys tell me which quantity of the displacement time graph lead us to the velocity? Angie, anybody? Yes. Which quantity of the displacement time graph leads us to the velocity? Anybody? Nobody?
Gradient sir.
Gradient. Very good, भाई. ओके, अच्छा, क्या आप इसका ग्रेडियंट निकाल सकते हो? यानी इसका ग्रेडियंट बता सकते हो कि किस तरह से ग्रेडियंट, लाइक हाउ द ग्रेडियंट इज वेरिंग? Okay, yes. Let me just continue it a bit further. Okay, so if we try to look at the gradient, so the gradient is basically maximum at the starting, and then zero, and then maximum, and then zero, and then maximum, right? But for that, just imagine a pendulum. Okay, so you have the pendulum. Okay, you know that at maximum velocity, sorry, at maximum displacement, the velocity is zero, right? So at maximum position, these are the maximum position, the velocity are zero, right? And at mean position, the velocity should be maximum, right? And you can see that this is the main position, this is the main position, and this is the main position. So these are the three positions where the velocity is going to be maximum, and these are the two positions where the velocity will going to be minimum, right? So we can relate that. Okay, so initially the velocity should be maximum 1, 2, 3. Okay, and then velocity will going to be minimum. Okay, and then maximum again, but in the opposite direction, and then minimum, and then maximum. Okay, so this is how the graph looks like. Let me just make it a bit correct. Okay. So this is how the velocity time graph looks like. Okay, and you can relate the concept of the velocity or the maximum velocity as v naught is going to be the maximum velocity with respect to time. Okay, with respect to time in seconds. Okay, so this is the second quantity we have right now. It contains some of the calculation as well, but I'm stopping the class right here because it's a namaz time as well, and we'll do the remaining of the velocity and the acceleration in tomorrow's class. Okay, and then we'll move on. Okay, so I'm stopping right here, and then we'll continue. Okay, challenge. That's it for today, guys. Okay, take care. Allah Hafiz.
Allah Hafiz, sir.
Allah Hafiz.